Okay. So, I will start now parallel programming, but we will keep it simple in the first task. Like today's lecture is reasonably simple, and codes are there in Colab now. So, you can run for 1 and 2 processes. So, this is called multiprocessing module of Python. Okay. So, this is a shared memory framework. So, several processes will work on the data simultaneously, but the data is shared, right, we discussed that. So, this shared memory framework, distributed memory framework we will do it later. Okay. But let us start simple. Okay. That is so in fact, this programming is not very difficult. So, this is a book which I took quite a bit of material from, and also a web page. So, multiprocessing, if you type, you will find a very good documentation on that, and I will not do all aspects of multiprocessing. I will do one what you need right now. So, what is the idea of multiprocessing? So, we have a data. Just think of data, I am just putting in one line, but it could be 3D data. So, we can partition it. So, I want to work with 4 processors. Okay. This data is residing in the RAM. So, we have a data and it is there in the RAM. So, let us do it for 4. So, I am going to this big data. So, I want to divide among several processors, so that it can be done faster. So, if all, so basically you have some 1000 copies to grade. So, we divide among 10 people. So, same thing is being done here. So, data is divided, let us say, among 4 processors. So, we need to, let us say, sine of x, and you do it for all of the data points and then sum it up. So, we define process, we create process, rather we do not, we create process. So, we create 4 processes. So, we discuss about processes in while teaching, while discussing about programming, right. So, there are process and threads. So, the main program, which is a master program, which is a one process, we will create more processes. This is called daughter processes. Okay. So, it will create sub process, and these sub processes will work individually on the data. So, this process 0, process 1, process 2, process 3, and you see that there is single code, the same code will run on all the process, but depending on the process ID is going to figure out which data to manipulate or which data to work on. Okay. So, why is it called multiprocessing? Because main program spawned this or created more process, and each process now is working on the data, individual data. And then finally, they collect, for example, summing up the data, summing up partial sums, no, this sum 1, sum 0, sum 1. So, these sums can be added up later. Okay. So, then all the sums are added. So, we will see how to first partition it, first create process, partition the data, so that each processor get their own data, and then how to operate on the results of the processors. So, processors have done some work, and we need to sum them up, for example, for total. Okay. So, these are things to be done, and this programming is basically sequential code. We do some more stuff, okay, on the sequential code. So, idea is for shared memory platform, this is for shared memory. Okay. So, the memory is shared by all the processors, every processor can see that memory. This module enables usage of multiple processes within a node. So, your laptop has, let us say, 4 processors, you can work with 4 of them. We saw in Numba, no, Numba we did not know what was being done inside, but there was a good speed up. So, you can do that with multiple processes in laptop or in a computer which has 32 cores, you can use it. Less bookkeeping than MPI. MPI has more bookkeeping, means more codes to write. We will discuss MPI later. do not get mixed up with that. And so, it also illustrates what is a process and how to create process. Okay. So, we will use several sub functions, basically sub modules, shared array and pool. Okay. So, I will show you how to use them. So, shared array has to be installed in Colab. So, in the code you will see that, but if you want to do it in your laptop, you can do it with Anaconda stuff. So, Conda install shared array will work. Okay. You should know how to install in your laptop various Python modules, if you like. So, that is done by Conda. Okay. So, why MP? So, actually, by the way, in a CPU we do OpenMP. So, this is with C++, we basically, well, I should not say CPU, with C++ we do OpenMP, Fortran OpenMP, but in Python it has several other options, like this multiprocessing is not part of not a thing for in C++, it is only specific to Python. Is simpler than MPI. This is OpenMP, it is like OpenMP. Okay. When I do OpenMP for C++, you see that this very similar idea, but well, Python is offering both thread parallelization and process parallelization. So, this multiprocessing is process parallelization. In the next class, I will do multi-threading. Okay. And threads or processes are different. Okay. That was a question in your exam, and we will see how they are different. So, MPI is more work. So, we want to avoid more work, and so there are various ways to do with with shared memory, and so basically what is the idea is, I think I mentioned it in while discussing programming. So, shared memory basically you keep the sequential code and you tinker with only some parts of the code. In C++ it is very straightforward how to do it, but in here in Python multiprocessing has slightly more syntax. Okay, it is very convenient. Okay. So, let us look at what is the structure. So, first we need to import multiprocessing. So, the module, and I import as import multiprocessing as MP. So, this is like import NumPy as NP, right, similar to, and so this process. So, we create a process, this is the process, and this process will work on a function. So, we have to create a function. Here is the my function is the target, that function will be executed with arguments. So, you can put your arguments like arguments of the function, no? X or sum and so on. Okay. So, this thing will come often in the code in next few slides. So, create process that executes the target function with the arguments args. But so, this is a common thing, and even in C++ you see this kind of structures, args equal to arguments inside. A process is a daughter process to the main process. So, the main program and this process is within the main program. So, we start the process by saying process start and end it with process join. So, there will be several processes or single process, you can start it and you can end it by join. Join, what does join means? So, this is the main process, remember this main process, and we create a process here P0, and that, so this is a timeline, okay, like in relativity you have timeline, right. So, the timeline, it goes, keeps going, and then it is doing, I mean this is doing its work and this is doing its work simultaneously. Then once this, so the main process will continue, but this process can end. So, this particle you can say that it has disappeared after this point. So, this join, this start. Okay, I hope this is clear. So, this is how processes are created and destroyed. This is like virtual particles, if you like. So, they are started and they at the end. So, this is a simple code which is interesting. They will give you an idea about what is process and sub process. So, we have a function. We have two functions. One function is info, other function is f function, okay, and there is a main function. Okay. So, you may see this main stuff like this, if name equal to main. I will discuss that bit later. Okay. So, what does this mean? But this is a main function. So, we import multiprocessing as process and import OS. Operating system gives you the IDs of processes. So, we have this OS get parent process ID, PP is parent process ID, and this is get PID. Okay. So, we start with this main. So, let us just see the sequence. So, I am going to run it now. So, when I run it, well, I am not running it here, I ran it on Colab and this is what I got. So, let us see how it moves. So, first thing is info main line. So, argument is main line, this right main line. So, what does it do? It calls this function. So, it says print title. So, title is main line. So, this is done. The next is print module name. Okay. So, what is the module name? So, this is a module which is started main, this one. So, main has come module name. Okay. This OS knows module name. Okay. Now, then parent process. So, parent process is of the main. Okay. What is the main parent process? Is 79. So, this is the main process, and okay, and when I call this function, now this is slightly tricky, process ID is 192. Okay. So, this is the parent process and this is the process ID of the main, this is process ID of the main. Okay. So, this is parent process is not of main. So, here right now our process ID is 192. Okay. Parent process is, so this guy has ID 79, then our main has 192, main has ID is 192, parent process the main has ID 192. Okay. So, this is guy is for here 192 is my process ID. Okay. And this function is finished, info is done. After that I go here. So, P process target F and this is I am creating a process P and is going to work, is going to execute function F with argument Krish. Clear? So, I created P. Now, what I do is I go to F. So, then is going to run info function F. So, it is going to call info from here. So, info will first print module name. Okay. So, print title. So, print title is function F, right. Then module name is main. So, module remains the same. Then get parent ID 192. So, 192 is the process ID of the main 192. So, for P the parent is 192. Who created process P? 192 created process P. But what is the ID of P? Its own ID. Process ID for P is this 25813. Okay, this is a daughter process, and this is a main process. Okay, is that clear? So, we had main process which is 192 and here we created 25813 and well it is continuous. So, well, I am sorry this is I made one mistake, I just take back. So, this is right now created process, it does not start execution. When I say P start, then it goes there and executes. Creation and starting is a different task. So, my timer starts from here, P start. So, P start means the process will start executing and P start executing means start running the function. So, when I P start, then I get all these results. And then print hello name. So, name is that Chris. So, hello Chris, and the P join. When I say P join, then that means the process, this daughter process stops. Okay, is that clear? So, we need to create a process and make the process work. So, let us do one more example. There I created only one process, but right now I want to have multi core. So, I want to create more processes. So, this is my parent process P 0, and at some point I create P 1, this green process, then this process ends. So, this is a join here, then create process P 2 start and join here, but all the time P 0 is present, okay? P 0 is not disappearing. So, once when it ends here P 0 is present, every time P 0 is present. So, P 0 after P 2 is done is present. Now, here this process P 1 and process P 2 do not have any overlap. Okay. Now, the second thing is I can start two processes one after the other. We do not need to wait for P 1 to end, then start P 2. So, start P 1, P 1 starts, then start P 2. So, P 2 starts, then after some time P 1 will join, then P 2 will join, okay. And then both are processes are killed, sub process, and P 0 survives, P 0 is present. So, for parallel programming, which one should I use, the top module or top idea or bottom idea? Bottom idea. No, we want to overlap these processes, so that they can do together. So, let us do an example. So, this is just printing the process ID. So, this function, my function, is going to be called. So, I create I do a loop for I in range 2. So, two processes I am going to create. So, process, this is going to create process, okay, and time it T 1. So, process start. So, this process will start now and it will execute my function, that is the target, but it is not executing at this point, but it is executing when P process starts. Then after that process join means process ends. Is going to this line will be finished only when process is done, and T 2 is time of now when its process is ended, and the difference will be T 1 minus T 2. Okay, I am recording both T 1 and T 2. Okay, and then it goes to the second I, does the same thing again. So, in this case, is there overlap between two processes or no? No overlap. Okay. So, this one, in fact, you can see the timing. So, starting point was 36.34 and 36.35, we just printed, did not take long. Then next one was 36.3561. Okay. So, this is after, and this is after process starts. You can do slightly more complicated work, and you can see that there is a these processes are occurring one after the other. Okay. So, that is what we get example, okay. No overlap. But if you want to overlap, then what should I do? I should create them and but join later. So, it is a simple idea. So, we create the so we append by the way. So, we create the process, append this process. Okay. So, this process is appended in processes. So, this processes will be a bigger list. So, process 0, process 1. So, the process is a bigger list where, so I need to keep those list of process, okay, and start. So, I create first process, I add here in the list P 0, then P 1, or if you are more than P 2 like this. So, all the processes have started now one after the other. Okay. You just start this process, but then after this you say, well, I want to close this process, join them. So, then process in processes. So, with all the numbers I say join. So, they will join once they are finished. So, that will be the case 2, which is like this. So, I start P 0, P 1, P 2, and then they will join here, they join here, join. Okay. So, now let us do some computing. okay, with shared memory with different processes in shared memory architecture. So, what is the strategy? So, I am going to do A star B. Okay. So, we have array A, array B, it is there in memory LAM. Okay. So, array A, array B. Now, so I want to, let us say, work with 4 processes, then divide the data A like that 4, 4. So, I need to know the starting index and end index, right. So, if process ID is I, then I star data size. So, data size I can compute, right. I mean, so total data size is n, double divided by number of procs. This is my data size in 1D, we will work with 1D, okay, correct. 4 processes we divide equally 4. So, I star data size is my starting array, array index. I start from 0, please keep in mind, process index will start with 0 and go up to I plus 1 data size minus 1. Okay. Is that clear? So, that is my index. So, I is the process ID, proc ID. And I just sum it up A star B, but my array is this part of the array, not the full array, okay, and that is what we will do. So, now, well, each process will do a sum and we call it local sum, and then local sum will be transferred basically to P0 main processor, and main process will add them. So, create shared array across process. So, A, B are shared arrays. Processor can burn on part of the arrays, the speeding of the code. Result sharing via multiprocessing. So, I am going to use manager. Okay, now that is what. So, this is a module of, is a sub module of multiprocessing, and manager will manage this. So, local sum dictionary. So, this dictionary is like a data structure dict. Okay. So, manager will create a dictionary, and which has, so it will create for process 0 this local sum. So, it will create a dictionary, right. I mean, so you understand dictionary, right. So, it will make a table, and then main guy will finish. So, manager is going to handle. So, this manager is created here. So, you will see this thing. So, target argument. So, this we discussed before. So, this line is same as what we discussed before. So, this is my code, is part of the code. So, next part will come in the next slide. So, I create 2 arrays random A and B. Okay. So, this is main. So, main will create a full array which is going to be shared by processes, and data size is n divided by max procs. So, it double slash, this is integer division, otherwise real numbers will be a problem for index. Okay, double division, double slash rather. So, it is integer division. So, local array mult. So, these are the 2 arguments, process index and local sum. Okay. So, initial index I just showed you initial index and end index, and I do a local sum for the process I. Okay. And by the local sum is a number for a unique number for each process, and you are not returning it to anywhere. Local sum has been declared as a dictionary for the by the manager. So, manager knows how to pull them up. So, this is a part answer to your question. So, we have some variable which is unique to the process, and that is stored in a table, and main guy will just add them up. Okay. So, this part is very simple. Now, we proceed further. So, manager is created here, local sum is a dictionary, a table, then a start time, process is created, a process is empty right now. So, this precisely what I did for creating process one after the other. Okay. So, target is my function and my arguments are I and local sum. I is my process ID, this is process ID. Okay. In C++ there is a, we use process ID as a variable, but here I is used as a index. Then join, after that I am just printing local sum, and local sum is available now to P 0. By the way, at this point all the dotted processes are gone. So, here only P 0 exists, the main process, and the main process will add them up. So, local sum dot values. So, these are like dictionary, local sum is not just a number or array. So, you have to pull them up, then you have to say local sum dot values, and so time it, the difference will give us the time elapsed between the starting the process and end of the process, or end minus time start. When I run it, I get this is local sum for process 0, local sum for process 1, and this is the total. This is sum, okay, sum, and the total time taken is 0.3368 . I should keep only 2 decimal places, okay, but this is just printing. Okay. It turns out I was bit delayed in the night, so I did not do a careful speed up calculations. So, with 2 process it should, we expect it to be half or near half. I was not getting on Colab. Okay. Now, we need to dig in why. So, there are a lot of overheads in multiprocessing. So, if the data size is big, maybe we will get a speed up, but we need to dig in. Okay. So, this is right now I am showing you the syntax. So, speed up we will discuss later. Yeah. So, values dictionary is a dictionary is not array. So, dictionary is a data structure and you have to pull values. So, this is the syntax. Okay. I am not deep into dictionary, but that is how you pull it. Local sum is not an array, it is a dictionary. So, let us use another trick called pool. So far I did my shared memory with manager. So, you can do pool. Pool is pulling together, let us pull together resources. So, that is in that sentiment this word pool is being used. So, the syntax is so let us pool creates a pool of processors or processes, actually not processors, pool of processes that execute multiple inputs in parallel. Okay. That is the idea of OpenMP. So, pool is, it works like this, pool multiprocessing dot pool. So, pool is a function and give the number of process, number of procs. So, it will create pool or data structure, okay. And then I can so pool dot map. So, it is going to map what? So, result of this function, the local array multi sum and input. Okay. So, I put the input to the local this function, and the result will be local sum. So, basically this is going to map for process 0 local sum is this, for process 1 local sum is that. So, that is what it is going to do. Okay. These are various syntax, you do not need to remember per se, you can just copy from the example. So, let us look at the code. The max procs is, well, you can choose one as well. So, it should work for one, or you can choose 2. So, this part is exactly same as before, this part is same as before, but I am returning now. For this part you need to return. Okay, now, these are some change in syntax. So, in the previous slide this guy wants an output. to be able to pull together to put the result in a table. Okay, map requires a result. And then in the main program, you can focus on these several lines. So, pool, I create this pool of processes, then local sum is mapped. The result of this is mapped into. So, input is, by the way, input is list of number of processes. So, this list is for 2 of them is going to be 0 1, for 4 of them is 0 1 2 3. So, local sum. So, this will just make a map. So, here what is the local sum for 0, local sum for 1, local sum for 2, okay. And then what do I need to do? I just need to sum this local sum. Okay. So, these are syntax. I mean, there are several ways to do it, and Python does offer multiple ways. You can test which one is faster, but I think they are roughly the same, same time complexity. Okay. So, this is different than manager, but inside pretty similar things happen. Now, we have applied async. Okay, this is another way to do it. So, asynchronous, async is asynchronous. We want asynchronous. In the sense, we can start things and they are all independent. Okay, asynchronous is independent. So, here pool is the syntax is slightly different. So, the function part is the same. Okay, the local sum, this part is the same function. So, I am not putting it in this slide. So, the results are in callback. Okay, so, this is syntax. This by searching in various parts of Google, and I got this. Callback collects the results in a list. So, this is the function. I put the argument and I get a result. Where should I put the result? I can't, is unlike map, you do not put it in some local array, you put it on some log result in a list. So, this function puts together all that. So, here you need to do more work. These results are put in a list. So, this is appending. Okay. So, appending the results. So, this is again part of syntax. You say why is it doing it? I do not know. This is just somebody did it, and these are kind of evolving. The Python parallelization is new. It is not 20-year-old stuff. So, some of it may go away, okay, and maybe one standard will come, but this is the status at present. And then you join them, close and join, first close then join, and then this is the result list. I want the total, then I need to sum it up. So, by the sum list sum is not available. So, I need to convert it to an array, then list and sum, or you could make a loop. So, the sum function is not available for list, it only works for array, it is part of NumPy. So, this is called np.sum. In any case, this is how we do it with the async, pool async. Okay. So, the numbers are roughly 0.38, 0.39, 0.4.